Hello guys, I am Oveshwara. I am going to talk with you our topic. Yesterday we already discussed about Gauss law. So in Gauss law we are discussing about a little bit. There is some of important points are there. So see, but Gauss law it is equals to what? Phi is equals to Q upon X. The electric flux with through a closed surface S it is equals to what? Q upon epsilon 0. And what is the Q? Q it is equals to total charge enclosed by the surface S. So see here our surface total charge it is our S. Okay, so see our this one total enclosed surface charge by this one, so it is S is that, so it is equals to what? Q it is equals to phi upon epsilon, Q it is equals to phi it is equals to Q upon epsilon 0. So see here what will happen, there is our Q upon epsilon 0 is that, so it is a electric flux closed surface enclosed by the surface, how much charge over there. So see now we are talking about the total flux phi, the surface is that phi it is equals to phi 1 plus phi 2 plus phi 3 up to where phi 1 phi 2 represent the cylinder flux through the surface 1 2 of the cross section, and phi 3 the flux through the curved cylinder part of the closed surface. So see in this figure there is a, see what will happen, there is a here first one it is a 1 2 and 3. So see this one it is we are talking about the three different flux is that, okay, three different flux is that. So three different flux have phi 1 phi 2 plus phi 3 is that. So cow cylinder part of the closed surface, now the normal to the surface at the three every point the perpendicular to E. So see phi 3 is equals to 0 further. Why? Because it is perpendicular to our electric field. So how can we say? So see we can return that see suppose here there is a one of cylinder, okay, one of the cylinder is that. So here field line, electric field line it is in this directions, and our this is our surface it is in this direction. So both are perpendicular to each other, okay, both are perpendicular to each other. So we can say that's why our what will happen, there is a flux phi 3 it is equals to 0. So now what will happen, there is a flux phi 1 and phi 2. So phi 1 it is equals to what? See there is a phi 1 it is that it have a our area is S. So we can say the flux phi 1 it is equals to what? Phi 1 it is equals to, we can written as phi 1 it is equals to our Q upon epsilon 0 is that, okay, Q. But for what will happen, the phi 1 it is equals to what? Here see the phi 1 it is equals to, we can talk about it, phi 1 into C there is a phi 1 it is equals to Q minus E1 H1 plus phi 2 it is equals to plus E2 H2. Why? Because there is a outward flux is that, okay, so outward flux is that. So that means what will happen here, there is a both are equal and opposite are there, outward normal to one opposite to E. So therefore what will happen, 2 is normal, 2 is along E while the outward normal of 1 is opposite to E. So here what will happen, there is a phi 1 it is equals to minus E1 S1 plus phi 2 it is equals to plus E2 plus E S2. So see here what will be, but suppose we are talking about that the S1 and S2 both are S, then our total outward flux will be 0. Why? Because of that the see there is we are talking about that the flux phi it is equals to what? Flux phi it is equals to, we are discussing phi it is equals to what? Phi 1 sorry phi it is equals to, we are discussing about these things. It is what? Phi it is equals to, phi it is equals to phi 1 plus phi 2 plus plus phi 3, okay, but phi 3 it is equals to, here it is equals to 0. But phi 1 and phi 2, phi 1 and phi 2 are both are equal and opposite. So see here my E1 S1 minus E1 S1 plus E2 S2, okay, E2 S2. So E1 S1 plus E minus E1 S1 plus E plus E2 S2. But here E1 S1 and S2 both are same. So see here S1 and S2 both are same at here. See. So what will happen? There is a, when we are talking about the close is that closed surface it will be zero flux is that. So see now the area of circular cross section area, thus the total flux is 0 as expected by the Gauss law. The whenever you find that the net electric flux through the closed surface is 0, so we conclude that the total charge contained in the closed surface is 0. So what will happen, there is a total to contain the closed surface is 0. It means we are talking about the closed loop circle. So closed loop circle, see this one it is our closed loop, okay, so this one it is our closed loop circle. So what will happen, there is a closed loop, it means here no outward flux over there, so we can talk about that outward flux, it is our zero. Okay, now the term of q on the right side of Gauss law, this equations, see in this equation, which equations, phi it is equals to what, here we can show in this equation phi it is equals to q upon epsilon 0. See this q upon epsilon 0 equation is that, so electric flux phi it is equals to q upon epsilon 0. So in this q upon epsilon 0, the true for any closed surface, no matter what is sorry, the term q on the right side of Gauss law include the sum of all charges enclosed by the surface. So it means what, enclosed by the surface means what? So see, suppose here this one it is, sorry, this one it is my see, this one it is our surface is that whole. Okay, so here one of the charge at here, one of the here, one at the here, one at here. So what will happen, there is a one at here, you shown there is a dot red point. So suppose we are talking about the inside of the total class, here one other also charge is that, but we are not considering. Why it is not considering, why we are not considering? Because of we are just talk about it only, those are enclosed charge enclosed by the surface. So those are charge it is inside of the surface, it is our, we are talking about that only, that phenomena, those are in enclosed by the surface. Okay, so we are talking about the q, it is our enclosed by the surface. Now the charge may be located anywhere inside the surface, it will be, maybe I have already drawn, it is a maybe at any another positions, maybe it is a end of the bottom, top of the bottom, maybe anywhere, but we have to talk about that the sum of all charges. Then after, see, any Gauss law, it is true for any closed surface. Any closed surface means what? Any closed surface means what? Any of the shape and size, it is does not matter on that shape or size, it is a, it is does not matter on that phenomena. So it is not depends on the shape and size. And the third one, situations when the surface is so choose that there are some charge inside the some outside the electric field, so is due to all the charge both inside and outside. The term q right side of Gauss law however represent only the total charge inside the S. So I already told you what will happen. There is a, suppose outside charge is also there, q1 q2 q3 up to qn, and also inside of charge is that q1 q2 q3 up to qn. So we have to just consider inside charge of the surface. Okay, not we have to consider the C. Suppose here what we are there, here we are drawn it here. Okay, so here what will happen, there is a C here, here this is our surface. Okay, so here all this charge it is at here 1 2 3 4 5 up to n charges is that, but outside charge it is outside of surface charge it is that. So we have to consider this charge, not only all this charge. Okay, not only all charge we have to consider, we have to just consider only one charge. Okay, inside of the surface charge. Then after we are talking about the next line, it is that the surface that we choose the application of Gauss law is called the Gaussian surface. So whenever we are talking about this kind of situations, this kind of surface, it is our, we are talking about the closed loop surface, and closed loop closed loop have a Gaussian surface is that. Okay, so we are talking about the Gaussian surface, so we can say it is our Gaussian surface. Okay, so what will happen, there is a Gaussian surface is that. So now we are discussing about the Gaussian surface. So you write down this all this point, Gaussian surface. Then after, Gaussian law is often useful toward the much easier calculations of the electrostatic field when the system have some symmetry. This is facilitated by the choice of suitable Gaussian surface. So whenever it is a symmetry, on that time it is a good for the counting of the our due to the Gaussian surface. Now finally, Gauss law is based on the inverse square of, depends on the distance contained in the Coulomb's law. So it is also again depends on the because here we are written as our flux phi is equals to E into dA, but E is equals to what? E is equals to Q upon 4 pi epsilon 0 into R square, 4 pi epsilon 0 into R square. But see, if it is due to that phenomena, what will happen? It will be a inversely proportional to the square of distance. Okay, So see, the any violations of Gauss law will indicate the departure from the inverse square law. And now afterwards there is a we are talking about the new topic. It is the application of Gauss law. So application of Gauss law, it is a three kind of applications. First one, it is a whenever we are talking about the road, infinitesimal road or wire, it is there. Second one, it is that what second it is my infinitesimal plane, okay, infinitesimal plane. And third one, it is a we are talking about that on sphere, okay. So see, now our another topic is that applications of Gauss law. So we are discussing about the applications of Gauss law. There is a three type of applications of Gauss law. Okay. So first one we are discussing about the applications of Gauss law. Infinitely long straight uniform charge wire, and then after infinitely charged uniformly charged infinite plane C. Then after uniformly charged thin sphere spherical cell. So see, what will happen? There is these three types of cells are there. The three types of applications are there. So we have to discuss about these three applications. It is very easy. First of all, it is that whenever we are talking about the large infinite symbol, okay, wire. So see, suppose we are talking about this is our large infinite symbol wire. Okay. So see, whenever this one it is our large infinite symbol wire, we are just taking as this area, particular area. Okay, this particular area. You can see here, I drawn it here from the chalk. You are just taking as this particular area. Whenever we are taking this particular area, on that time, what will happen? The wire, the current it is going from that the inside of the wire, inside of wire. It is a spherical surface. Okay, our sorry, it is a wire. So what will happen? Infinite symbol large. So see, what will happen? There is a electric field. It is in this direction. It is perpendicular in this direction. It means what? See, it is in this direction inside of the our wire from the center, and all will happen. There is our surface. So both are in now parallel. Okay. So see here, what will happen? There is a our DA. Okay, DA. This is our we have just considered area, and now our electric field. So here I written as our electric field E. E is our both are in parallel form. Both are in parallel form. So whenever it is in parallel form, all the time what will happen? The our flux will be maximum. But see, whenever it is a perpendicular, so see this one it is my surface area 1. Okay, see this one it is my surface area 1, and this one it is my surface area 2. So see here there is a flux phi 2 from here and here, phi 2, phi 1 and phi 2 both are 0. Why 0? Because of that. Why 0? Because of that, whenever we are talking about that it is a perpendicular. So perpendicular it is equals to what? We have written in what? E dA cos theta. But E dA cos theta. Theta is equals to 90. On that time our flux will be 0. Flux will be 0. So here flux will be also 0. When here we are talking about the phi 2, that surface 1 of the cylinder and also surface 2 for the cylinder. So see, whenever we are talking about the surface of cylinder, on that time this flux phi 2 and flux phi surface 2 for flux phi 2 it will be 0. So when we are getting at the flux, so flux we are getting it here. When see our flux permanent is phi is equals to phi 1. Okay, so phi 1 is that it is perpendicular to our electric field. Then what happened? We have to check it. Okay. So now see what will happen. We are discussing about that there is three type of three flux phi 1, phi 2 and phi 3. But here what will happen? There is something is cheating is that we are talk about only this flux phi 1 we have to just consider. But first of all we are discussing about the line charge density. So yesterday we are talking about the line charge density, what it was that. So see, line charge density we are written as lambda is equals to q by n. What we are written? Lambda is equals to q by n. So now line charge density. So what is this? See, this one it is a line charge density. Now what is the line charge density? Line charge density we had yesterday we had talked about it. Lambda is equals to what? Q by n. Lambda is equals to what? Q by n. So lambda is equals to Q by n. It point P and point Q are what? It is perpendicular phrases from our line chart distribution. So see here, over this line chart distributions are there. Here it is our point P and point Q. It is both are perpendicular to here. So see, point perpendicular to here is that. So now see, then after we are talking about the what? We are talking about our Gaussian surface. Now what is the Gaussian surface? So see, this one we are talking about this area. This area we are talking about it. So it is our closed loop circle, our closed loop cylindrical. So we can say this is our Gaussian surface. This is our cylindrical Gaussian surface because we are considering as our what? We are considering as our closed loop surface. So whenever we are talking about the closed loop, on that time it will be our what? It will become as our Gaussian surface. So now whenever we are talking about the Gaussian surface, it is our this kind of cylindrical Gaussian surface is that now it have, see, it have radius, it is r, radius it is our r it is our radius from here to here, it is my radius, and now see this one it is our length, it is r, l it is our length, from this point to this point it is our length, l is that. Okay, so what will happen, it have a length l is that, so we can say this one it is our length. So now we can talk about it. See what will happen, line chart distribution. So the area of this curve surface of cylindrical is 2 pi r. Why we can say 2 pi r? Because of whenever we are talking about the cylindrical surface, whenever we are talking about the cylindrical surface, on that time what we have to say, we have to know about the it is area of the curve surface. It is 2 pi r. It is a formula for the measurement of area of cylindrical. It is a formula of what? It is a formula of measurement of area of the cylindrical surface. So we can written as our cylindrical surface area is equals to 2 pi rl. And then cross section area. Now what is the cross section area? So suppose see here what will happen, there is a bunch of coin over there. Okay, bunch of coin over there. Here also one of the bunch of coin is there. Now one coin, we have just taken one coin, or suppose it is a 10 rupees coin, or suppose it is a 1 rupees coin. So we have just take 1 rupees, what? 1 rupees coin we are take, and we can get the how much area of this, coin. So it will give, where whenever we are multiplied with our number of coin, so we can get the total our area. So see, whenever we have just one line, it is your what? It is your cross section area. Or suppose you are just cut your what we can say watermelon in the part of that, but you are just take one slice of this part of the our watermelon. It is your cross section area. What? It is your cross section area. So clear in your mind? Now what is the cross section area? So see, whenever we are talking about the cross section area, it is my pi r square. Why pi r square? Because of that it is a circle. So circle have cross section area. It is what? It is our area about the circle. So we can say section or cross section area of the our any particular value. It is our pi r square. So afterwards, what will happen? The charge q. Now what is we have the measurement of the charge value. Okay, charge q. So charge q is equals to what? Charge q is equals to lambda into L. How can we write? I already explained you what before that line chart density. Line chart density is lambda is equals to what? Q by L. So we require value of Q. So lambda is going in this side. So lambda into L it is equals to what? Lambda into L it is equals to Q. So we can written as charge Q is equals to lambda into L. So I already written here lambda into lambda is equals to Q by L. Now what we are talking about the close. See, I written as open, but why it is a so whenever we are talking about the closed circle, so you will write down this kind of symbol at here. So round off. Why? Because of that we are talking about the closed loop surface. Okay, closed loop area. So on that time, the closed loop area E into dA. So E into dA we can written as our A under dA is equals to what? Q upon epsilon 0. So see here we can written as here Q upon epsilon 0. Okay, so q upon epsilon 0. But see here, dA is equals to what? Surface close the Gauss surface area of our cylindrical. Okay, so Gauss surface area, so it is equals to what? We have value, it is equals to 2 pi rl. So we have to put the value of dA instead of our dA, we can write 2 pi rl. So integration of close integrations of e into close integrations of e into dA it is equals to what we are writing? We are writing 2 pi rl. So 2 pi rl, it is equals to what we have value, it is equals to pi of according to Gaussian law in closed loop integrations of E into dA, it is equals to Q upon epsilon 0. So we have to write down Q upon epsilon 0. So flux phi it is equals to what? Q by epsilon 0. Q upon epsilon 0. Okay, but see what will happen? There is a 2 by RL into E. So now this L, this all the whole term we require what we have to measurement. See, infinity long state uniform charge wire. You have to measure electric field. What you have to measure? Electric field due to. What you have to measure? Field. Field due to when? Field is electric field due to when? Infinitely long straight uniform charge wire. What you have to measure? You have to measure infinitely long straight wire, uniformly charged wire. Okay, infinitely long straight uniformly charged wire. We have to measurement of that field. So field E is equal to. So we are going to make the value of what E is mean. So E is equal to what? E is equal to Q upon L. Q upon L 2 pi r into epsilon 0. But again, what will happen? Our Q upon L it is equals to what? Q upon L it is equals to lambda. Q upon L it is equals to what? Q upon L it is equals to lambda. So lambda we have to put it. So E is equals to, we are getting that electric field. E is equals to what? E is equals to lambda 2 pi epsilon 0 into 1 by r. So into 1 by r. So see here, one of the conclusion is that whenever we are talking about the long straight infinite symbol wire, is that on the time our electric field it will vary with the our distance r. It is vary with the inverse of the distance r. Okay, inverse of the distance r. So it is vary with the inverse of the distance r. So electric field E is equals to what? Lambda by 2 pi epsilon 0 into 1 upon r. Lambda by 2 pi epsilon 0 into 1 upon r. So it is our what? It is our electric field when long straight in uniformly charged wire, infinitely long straight uniformly charged wire. So I hope you understand this topic. It is a very easy topic, but see now when we are talking about that, it is a graph of nature. So graph of nature where we have to draw. So see here, I just drawing this page. Whenever our electric field is at here E and downside it is my what? Our r. What is r? R it is our distance, okay? Or r it is our what? It is our radius at here. So what we can say? If it will be increased, then it will be our electric field will be going to decrease. Okay? Whenever r it is increased, then sorry. What will happen? Our r is going to increase, then our also this is value with this things. So electric field will be going to decrease. Okay? Inversely proportional of that. So R is increase, our electric field will be. So see this one, it is our graph is that. So see what will happen? E is increased, then R is decreased. R is increased, then E is decreased. Okay. So what will happen? So R is increased, it is going to increase, then our electric field will be going to decrease because it is proportional, inversely proportional to that. What? It is inversely proportional to that. So this is our topic of that. When first topic of application of Gauss law. Now second topic it is what? Uniformly charged infinite plane sheet. Uniformly charged infinite plane sheet. So before the I going to next topic, you have to write down this one. Afterwards we will discuss our next topic, uniform charge infinite plane sheet. But before that you have to write down this one and you have to send me on our Google classroom. So you have to guys please keep, I hope you shown properly of the video. So you write down this one. So now our next topic is that uniformly charged infinite field due to what? Uniformly charged infinite plane sheet. Okay, so it is due to what? Infinite plane sheet. So whenever we are talking about the infinite plane sheet, so plane sheet means what? Sheet means, suppose, see what will happen. Suppose we are discussing about the sheet. So again, that just I am drawn. There is a same sheet cylindrical. Okay, but here we are talking about that it have a sheet. Okay, it have a sheet over there. So see what will happen. There is a sheet. Okay, so see here what will happen. This one it is our seat, understand? This one it is our seat over there. So seat have what will happen? It have a charge which is plus here. Okay, so we have plus charge, our charge is there and it is our Q. So see now what will happen, there is our surface, it is there here, but our electric field it is in this direction, electric field it is in this direction. So see this one it is our electric field, also our electric field it is in this direction. So see here we are talking about that the whenever now again what will happen, now this field or this field and this both are in now perpendicular. So see we can talk about that there is a how much surface, one, this one it is my two, and this one it is my third surface. So 1, 2, 3 surfaces there. So see now what will happen. So these both are 1 and 2. We our surface 1. Okay, surface 1. Which surface? Surface 1, it is what? It is parallel, covered parallel to electric field. So 1 it is parallel to electric field, and second it is also parallel to your electric field. But third one it is not parallel. It is a perpendicular to our electric field. So whenever we are talking about this flux, so flux phi is equals to what? We can say the flux phi. We require the flux. First of all, we are measuring the flux phi. But before that, we are talking about our see this we take the area. Okay, so cross sectional area and the length of 2r as a Gaussian surface. Because of see what will happen, there is a we are talking about the see, we take the cylindrical cross section area A and length is 2r as the Gaussian surface. On the curved surface, the cylindrical is E and here n is the perpendicular to each other. So n can here what will happen, there is a two surface is the two distance are there. So this one it is my C, this one it is our R, and here also this one it is my R. So that's why we can say it is we are taking as this 2R. Okay, we are taking as 2R. So whenever we are talking about 2R, on that time what will happen, so 2R is that it means here we are talking about two surfaces that. So now what will be there here, there is our n cap. N cap is what? N cap is our unit vector of that field phenomena. So see we are talking about the n cap is that. Now we are talking about the flux phi. So flux phi, before that we are talking about the surface charge density. What? Surface charge density. Surface charge density. Now what is the surface charge density? Surface charge density is equals to what? Surface charge density is equals to sigma q by a. Okay, sigma q by a. So sigma surface it is denoted by surface charge density. So sigma is equals to what? Q by a. So if we require the value of q, it is equals to what? Sigma into a. If we require the value of q, it is equals to what? Sigma into a. So whenever we are talking about is sigma into A. So what will happen? It is our surface charge. But according to again what according to Gauss law, according to according to Gauss law, what will happen? Flux phi is equals to what? Flux phi is equals to Q upon epsilon 0. Whenever we are talking about whenever we are talking about Gaussian surface, or whenever we are talking about the closed loop surface, we have value of phi is equals to value of flux phi is equals to what? Flux phi it is equals to Q upon epsilon 0. But again we have requirement of the closed surface. So flux phi is equals to what? Q upon epsilon 0. So there is a two field is that flux through the flat surface is that, see here what will happen here, flux here it is area, it is our A, and also here what will happen, this one it is my area A. Both are in our, so flux phi is equals to related to our two surfaces. So phi 1 plus phi 2 is there, okay. But flux phi 1 into what here EA is there, plus again phi is equals to EA. So again what will happen, it is a 2 EA value is there. What? It is a 2 EA. Now here what is E? Here E is equals to our electric field. E is equals to what? Electric field. Okay, E is what? Electric field. 8 is my area. 8 is my what? Area. Okay, so 8 is my electric field and 8 is my wire area. So what we can written, flux phi is equals to 2 EA. But according to what? According to Gauss law, what will happen? According to Gauss law, from equation number 1 we can say the Q upon F phi is equals to what? Q upon epsilon 0. It is equals to 2 EA. Okay, but see again what we have to measure? Uniformly charged field. Due to what we have to measure? This field due to what? Charge infinitely plane C. We have to measure the field due to uniformly charged infinitely plane C. So here what we have to measure? Here we have again measurement of our electric field. So electric field it is equals to what? We can say Q upon Q upon A into 2 epsilon 0. Q upon A into 2 epsilon 0. But again, what will happen? See, what will happen? There is a Q upon Q by A is equals to what? Q by A is equals to sigma. Why? So sigma it is equals to Q upon A, because it is a what? It is our surface charge distribution or surface charge density. What we can say? We can say this one it is my surface charge distribution, or we can say surface charge density. Okay, so we can say surface charge distribution, or we can say surface charge density. So see again here what will be the here Q upon A. So E is equals to what we written? E is equals to sigma upon 2 epsilon 0. So sigma upon 2 epsilon 0. So it is our surface field due to the uniformly charged infinite plane C electric field. Okay, so what will happen? So see, if E is independent of R, the distance of the point from the plane charge of C. So see here what will happen? In the first of all we are getting that the E of E is equals to lambda upon 2 pi epsilon 0 into 1 by R. So whenever we are talking about the line charge, it is related to what? Lambda upon 2 pi epsilon 0 into 1 by R. But whenever we are talking about the what? Whenever we are talking about our one plane C, okay, plane C infinite plane C, on that time it is not depends on the value of our R, but it is only depends on value of our what? Value of our sigma and also our epsilon 0. So it is depends on constant value. It is depends on our constant value. Okay. So sigma it is equals to what? Q upon area. So Q upon area is Q. It is what means what? Q it is our charge upon area. Charge upon area. So this one it is our topic is that what? Our topic is that volume field due to the uniformly charged infinite plane C. So you can easily understand this topic. So I hope you are understand and I hope you enjoy this lecture. But now still our one topic is remains still. What is that uniformly charged thin spherical cell? So it have also two parts. It have also what? Two parts. First one, it is a line inside the cell. So line inside the cell means what? See, suppose here what will be there? Here one of the ball is that. Okay, one of the ball is that. Now ball of inside. We have to talk about the inside of ball. So it is our. We are talking discussing about the line inside of the cell. So cell means what? So just we are considering as a our volleyball is that. Okay, so volleyball. See our cell. See we are so just our in this art. Okay, the see, so what will happen inside of the cell? So this one it is our cell, okay. But now we are not talking about the surface, but we are talking about the inside of the surface. So first one it is our topic is that inside of the cell, and second topic is that what? In first topic it is our inside of the cell, and second topic it is outside of the cell. How much electric field are there? So we have to measurement of how much electric field are there whenever we are talking we are discussing about this situation. So inside of the cell or outside of the cell. So this is our topic. After this you have to just first of all complete this one, you have to write down, and then you have to send me on Google Classroom this topic also. So this is our second topic, uniformly charged infinite plane sheet, okay, when field due to uniformly charged infinite plane sheet. And then after we are discussing about our next topic, uniformly charged in spherical shell, and discuss with these two another topic. Okay, so first of all you write down this one, and then I am giving time to you, so you write down. Afterwards we are discuss our next topic. So I hope you have written this question. Now we are going to our next question is that so now guys we are going to next lecture. Before that, first of all you not in your note it down. This is your homework. Homework is that first one is the define the Gauss law in details. Second one is that how flux is vary with the angle. Okay, how flux vary with the angle. It is your second question for your homework. And then third, field due to the infinitely long straight uniformly charged wire. You have to describe your all this whole topic what I have written on the board. You have to write down and you have to send me. And then after third one is that fourth one is question is that field due to the uniformly charged infinite plane shape. So you have to write down this all these four questions and you have to send me on the Google Classroom. But guys, please keep in your keep study, because yesterday soon there is a not shown these videos properly, and you have to just that's why you are not sending me your homework. So that's why today I am giving me the last of the end of the video I am giving homework. So guys, you check it and you have to send me. And also if any doubt, if any correction, then you guys send me any of the doubt, any of the correction is that you have to send me on the Google Classroom, as well as you can talk with me on the YouTube comment box. Okay, but please guys focus on study. If any doubt, then send me. Okay, I will give the definitely I sure I will give your questions answers. So guys, please keep studying. Okay. So Steve, today we have discussed this much only. After this one, we are talking about another remaining question: uniformly charged thin spherical cell and lying inside the cell and outside the cell. We are discussing on in the our next video. Okay, but still we are just discussing about first topic over that. What was that? It is our Gauss law, and now second is that our infinitely long state one. The third is our uniformly charged infinite brain is there. So I hope you are enjoy these lectures. Okay, please guys do comment. Please read carefully. Okay, thank you guys. Thank you so much.